Today I'll be discussing on cloud security and its privacy issues. So, coming to the introduction outline of my presentation today. So, it is as follows. The first part will be the introduction, motivation, its application, and what are all the possible solutions in the cloud security and privacy, and what is the overall assessment that I could make after doing all this research, and then the conclusion for this presentation. Finally, I'll quote some references that I have used to make this presentation. So, introduction for cloud security and privacy issues. First, we'll be going through the background of the cloud computing and then the cloud models, and then why do people still hesitate actually to use the cloud computing here when cloud is very good option and it gives the remote space for the storage of the data. Then why people still hesitate to use the cloud computing, we'll be discussing that in detail. And then the causes of problems associated with cloud computing, then taxonomy of the fears, and then the threat models that are pertaining to the cloud computing. So the background of cloud computing will be, first, to understand what cloud computing actually is, we need to discuss the background. So the background is as follows. So the use of internet service to support business processes is called as a cloud computing. So what you basically do is, as the companies in IT companies and the other companies, businesses have a lot of data, so they cannot afford, in most of the situations, they cannot afford to just have their own storage spaces, so they go for the cloud spaces which are provided by the cloud providers. So basically, the businesses that have a lot of data, they need to store the data for the processing, which is very confidential. So it is not possible in every case to keep the servers and maintain the data on their own servers. So the cloud computing is possible. So what are the attributes of cloud computing? Why people use cloud computing? What are the main characteristics of the cloud computing is as follows. So it has very rapid deployment. So it doesn't take a very long time for deployment of the cloud computing. And for starting the services of cloud computing, you do not invest a whole lot of capital in that. And it is not the thing that you need to take a huge space initially and then start storing your data. As company starts gathering the data, it starts storing the data in that process. So cloud computing, the characteristics, one of the important characteristics is that, so it is cost based on usage or subscription. If you have small data, you take a small storage and store the data. And if your storage usage is increasing, then what you do is you increase the subscription that you take for the presentation. Also, one of the other important aspect of cloud computing is it is a multi-tenant sharing of services and resources. So in a single cloud, it is not for a single customer, it is for the multiple customers. So a single cloud provider will give the storage for the different customers. So it is multi-tenant sharing. And this cloud computing is location independent and resource pooling. So what does this mean is, for storing data, you need not have a particular space for that. You can directly store your important data onto a remote place from wherein you can access the data at any given time. So it is not location independent. It is not location dependent, it is location independent. And the services that you are using is a measure. What does this mean is, whatever data you put on the cloud, it is the data capacity that you have. So the standard definition of the cloud computing will be compilation of existing techniques and technologies packed within a new infrastructure paradigm that offers improved scalability, elasticity, business agility, faster startup time, reduced management cost, and just-in-time availability of the resources. So this was the standard definition of the cloud computing. Now coming to the massive concentration of the resources. So if you are getting a concentration of resources, it is obvious that you have concentration of risk. When you get too many things at place at very ease, then there are a lot of chances of you getting a breach on that issue. And when other, as I have already said, as it is a concentration of resources, then it is concentration of threats. So it is obvious that when you have something concentrated good at a place, then people might find ways to break into that, and your security breach can happen very easily. Ultimately, you can outsource responsibility, but you cannot outsource accountability for that. And cloud computing, why? Who should use the cloud computing? It's a question now. Cloud computing definitely makes sense if your own security is weak. Missing features are below average. If you don't have the security for your data with you, then cloud computing is a perfect solution that you should look upon. Ultimately, if the cloud provider security people are better than yours, then you should go for the cloud computing. The web services interfaces don't introduce too many new vulnerabilities, and the cloud providers aims at least as high as you do at security goals. Then cloud computing has better security. So whoever doesn't have their own security for their data and their processes, they should surely go for the cloud computing because it gives you a better security. In the cloud model, what are the cloud models that are available in the market is as follows. So the delivery models for the cloud are SaaS, PaaS, and IaaS. SaaS stands for software as a service, PaaS stands for platform as a service, and IaaS stands for infrastructure as a service. So what is software as a service? So in this, the service that you get is in form of a software. Like for example, it is an application based, like Google Documents. Google Documents, one of the good example of cloud for the SaaS is Google Documents. So Google gives the Google Documents as a service, as a software as a service, and then you could use that to store the data on the cloud with the Google platform as a service. Example for that is the programming platforms such as Django and the other services, other platforms will be the example of platforms as a service. And the other examples in software as a service would be basic application services such as OpenID and open source are other examples of software as a service. Infrastructure as a service, you can have a big infrastructure as a service and small infrastructure as a service. Means the higher infrastructure service and the lower infrastructure service. In higher infrastructure service, the example of that will be Google Big Data. Google Big Data is an example of higher infrastructure as a service that is given by the Google, and the computational resources that are given by Google. The other example in infrastructure as a service will be Hadoop. So this is nothing but the big data concept. So what Google does is it will give you an infrastructure wherein you can arrange the data, store the data, and predict the models for the data. So these are the models of the clouds that are being provided by the cloud providers to their clients. Deployment methods, you can have a private cloud only for you, not for anybody else. You alone store your data in that, and the other will be the community cloud. It is basically a multi-tenant cloud. Public cloud, it is a free cloud, usually a free cloud wherein you can just put on the data, but the storage capacity on that cloud will be very small. And the hybrid cloud is a latest type of cloud wherein it have got too many advantages for the hybrid cloud. And the management models are self-managed, that you maintain your cloud by your own, or the third party managed that you own a cloud but its security is managed by other people. So the management model that I've already discussed will be of two types: self-managed, that you own the cloud and you look onto the cloud, and the other will be you own the cloud, but its management will be looked by the third party. So it is called as third-party managed cloud. Impact of cloud computing on governance structure of IT is as follows. So the organization has a control, organization shares the control with the vendor, and now the vendor will have the control. So this model that you can see in this slide is basically for the third party managed cloud. In the management model, as we have already seen that there is a third party managed cloud. So this is how it will be. So on the premise, what we will have is we will have the application, the virtual machine, the server, the storage, and the network. And what we as a provider is hosting is the application VMware. The server storage network will be on the other side. So infrastructure as a service. In this, the application will be on the other side. The VMware will be on other side. On same side, we will have server storage in the network. And then platform as a service, as we have already discussed, that the platforms can be as a Django and the other platforms that are given by the providers. In this, we'll have application services with us, and the other things like server, storage, and network with the other things. Then software as a service, we'll have application service, server, storage, network, all with the vendor control. So in software as a service, application service, storage and network, all the control of this will be with the vendor, not with the organization. If cloud computing is so great, then why isn't everyone doing it? Is the question that we need to discuss now. See, as we have discussed all the advantages and all the benefits of the cloud computing, then why everyone is not using that? And if they are using, then why they are why they are just suspicious about using the cloud computing is the next question. So this will be the explanation for the people not using cloud computing or people hesitating to use cloud computing. It is like a big black box that you use the services, but you don't know what is all inside that. It is that you will have the things that you are storing on the cloud, but you don't know what else is stored in the cloud and who else is operating on the cloud and who else have the control over the cloud. You don't know that. Clients have no idea over the control, what happens inside the cloud. Even if the cloud provider is honest, it can have malicious system admins who can tamper with virtual machines and violate confidentiality and integrity of the cloud. So obvious that when you have given your control to the vendor and the provider or the other people who is managing your cloud, then it is always the issue of the integrity and the confidentiality of your data and your processes that are stored on cloud. Cloud is subject to traditional data confidentiality, integrity, availability, and privacy issues, plus some additional attacks. So the CIA trade, the main things that is common for all type of data is the CIA, confidentiality, integrity, and availability. So for the cloud, these three are for sure. And apart from this, we also have some additional attacks. So we are trying to see that what is making a company hesitating or resisting a company from using the cloud. So the security matters now. As we can see in this figure, that the security is becoming a factor in 74.6% of the cases, and now in performance part it's 63.1%, that the people are still worried for its performance, that whether if they store data on the remote clouds, whether they can retrieve it back or not on time, whether its availability will be guaranteed or not. People are suspicious still about that. And as we have already said, that cloud is a location independent place. So what else makes it think for the clients to use that is in-house integration with IT services to the cloud. And what else 55% contribute 55% And contribution of the clients not using the cloud is because of the customizability that it doesn't offer to the cloud. So people are basically worried. The other factor is the worried on demand will cost more as the services by the cloud providers are given on demand. So people worry that it might cost them more. Bringing back in house may be difficult because they are giving the data out, and again, if in future they want to maintain their own cloud data, then bringing back that would be a costly issue. And then the regulatory requirements prohibit the cloud, not major enough suppliers yet for the cloud. There are very few suppliers of the cloud in the market, and they are very expensive yet, because is the reason that makes people hesitate to use or resist to use the clouds for now. Now the causes of problems associated with cloud computing. So most security problem arises from loss of the control, that clients and the users of the cloud fear that they might lose the control over the cloud, and lack of trust that the provider or the the party that is maintaining in the cloud may not be that trustworthy. And of course not, but the multi-tenancy part, that each cloud that is provided by a vendor, it might give the same space for this for different clients might store different type of data onto the cloud. So these problems exist mainly in third-party management models, not in the privately managed models or self-managed models. Loss of control in the cloud. So what exactly is the meaning of loss of control in the cloud? So data application resources are located with provider. User identity management is handled by the cloud. User access control rules, security policies, and enforcements are managed by the cloud providers. And also in this, the consumer or the person who is or the company who is using the cloud, what they have the problem is data security and privacy, resource availability, monitoring and So we were discussing the problems that are associated with the use of the cloud, and we looked at the loss of control in the cloud should be the first problem, and coming to the next one, that is the lack of trust in the cloud. So if it is a cloud that is managed and provided by the third party, then the problem for the client using that should be the lack of trust in the cloud. So defining trust and risk, opposite sides of the same coin, and people only trust when it pays. If you pay and use something, people tend to trust it. If it is provided for free, then people usually don't tend to trust that. And when people go for paying for the cloud, then the providers just make that service costly. So need for the trust arises only in risky situations. If the cloud is owned by you and you have got a proper set of security, then that risk part between you and the provider doesn't come into the picture. And also the lack of trust in the cloud covers defunct third-party management schemes. Hard to balance trust and risk. Example is key escrow, that is a clipper chip. You need to be aware of the clipper chip, and is the cloud headed towards the same path will be the question that covers the lack of trust in the cloud. Multi-tenancy issue in the cloud is the problem again that is associated with the use of the cloud. In this, the conflict between the tenants having the opposite goals. So if the tenants of the cloud have multiple goals and opposing goals, then it should be a problem for both of the means all the tenants that are part in the cloud. So how we can deal with this multi-tenant issue having opposite goals? So if this is a question, then what will be the solution for this is, can tenants get along together and play nicely, but they are still having their opposing goals? And if they can't, can we isolate them on the same cloud is the question. And how to provide separation between them? Okay, if we got to know that they cannot play nicely and we got to provide isolation between them, then how can we provide the isolation between them? And how to provide separation between the tenants? is the thing that we need to consider for this now. Cloud computing brings new threats. If we go for cloud computing, as it is a new technology and it have got two good benefits, so along with that, we should be facing some threats with that. So multiple independent users share the same physical infrastructure. Users are different, the clients are different, but they are using the same cloud. So here the risk arises. Does an attacker can legitimately be in the same physical machine as the target? So for instance, uh, if I am a businessman of a particular business and I have taken a cloud storage of a particular provider, then my rival and my business competitor can also be storing their data in the same cloud. So here the opposing goals will be in the same cloud. So this will create a problem now. Now, coming to the taxonomy of here, confidentiality, as we have already discussed, comes into the picture. So, what is confidentiality exactly in the context of cloud computing is fear of loss of control over the data. And will the sensitive data stored on the cloud remains confidential is the question, and that arises here. Will the cloud compromise leak confidential client data is again the question that arises. And will the cloud provider itself be honest and won't peek into the data? We need to just keep that into the mind when we are taking an out third-party managed cloud services. See, the cloud provider and the client needs to have a good relationship, or else the provider can just leak the data of its client to the other business rivals, which may cause a very big issue. So keeping the data confidential by the provider is very important here. Integrity of the data. Integrity means the form in which the data I have stored, its integrity is maintained. So how do I know that the cloud provider is doing the computation correctly? If my cloud is required to do some computations on my data, so whether I can trust it for the computational results that it have given to me. So this is also the question that needs to be considered here. And finally, the availability of the data. Okay, for availability of the data, availability as it is clear from the word that means the data that you're putting on the cloud is available at the all time, and on request you're being given again the access of the data. So will that be an issue? Yeah, surely. For cloud, when information and data is stored on the cloud, the availability can become an issue and availability can be compromised. How? If the denial of service attack is being launched onto the data, then it might cause you to get an availability taxonomy of fear here. What happens if the cloud provider goes out of business? If the cloud provider is no longer giving you the space, so suddenly what happens if your business is running on and you need to, and availability can also be compromised is if I am storing my data into the different clouds, but that clouds are provided by the same provider, then would cloud scale well enough will be the question. Often wise concern is what although cloud provider argues the downtime compares well with the cloud users own data centers. When a provider owned cloud and the client, if they own their own cloud, then the downtime for the both of them will be same, is what is claimed by the providers. And privacy issues raised by a massive data mining, as data mining is playing a very big role in the technology and the sorting of the data and the operations on the data. Then for the cloud, data mining is also a very major concern. So cloud now stores data from a lot of clients. They have different clients that store their data onto the cloud, and now this data can run data mining algorithm to get large amount of information on the client, the pattern of the clients, the different and important patterns, and that the client is storing data onto the provider. They can get that pattern, and at any given point, by getting a pattern, they might enter into the communication link of the client on the cloud and might cause any breaches of the privacy issues here. And increase attack surfaces. entity outside the organization now stores and computes data, and so attackers can now target the communication link between the cloud provider and the client. Cloud provider employees can be phished. The employees that are with the provider, that are responsible for maintaining the clouds, for servicing the clouds, and for performing and for checking that whether the clouds and the algorithms that are present on the cloud for the computational purpose are working or not. So the employees that are responsible for maintenance and service of the clouds can be phished and can be, and thus the breach of the data can occur. So auditability and forensics. So the data on the cloud should be auditable. So difficult to audit data held outside the organization in a cloud. Forensic data also made difficult since now clients don't maintain data locally. As data is not maintained locally, it is put onto a remote location. So the auditability and the forensics of the data is not that good with the client. And the laws, if in chance some breaches happen, then what are the laws that can prevent the privacy of the data and that safeguards the privacy of the client? So we have different laws that are designed by the American Constitution, such as HIPAA, for protecting the privacy and the private data and sensitive data of the businesses and different clients. If the cloud provider subcontracts to the third cloud, will the data will still be secured or not? Will again be a question. In taxonomy of fear, cloud computing is a nightmare, and it can be handled in traditional ways. So, no doubt, if you don't provide certain in safeguards, then it might be a nightmare. But you also have traditional methods to just stop that nightmares. So attack with catastrophic effect only needs one security flaw. If they find one security flaw, they'll just get into the network. The threat model helps in analyzing a security problem, design mitigation strategies, and evaluate solutions. So steps in threat model. So now after knowing what all the loopholes in the security of cloud computing, we are moving towards the threat models. So steps in threat models are identify hacker, assess threats and other components, rank the threats. After you found out your threats, rank the threat according to their most occurrence. And after that, choose the mitigation strategies, build solution based on the strategies that you have chosen. So the models for the threat is as follows. First, you identify, rank them, and then choose the mitigation step in order to stop their attacks, and then you build the solutions for them. Basic components of the threat model will be attackers modeling, that what all the attackers can do and what they can do and what capacities they have to, and whether it is an insider and outsider, whether the attacker is a single or a collaboration or a group of attackers, and what is motivating attackers to get into your network and get into your space and take your data or modify the data. What are their goals? What are the vulnerabilities? These all needs to be covered here. So issue is what now? The core issue here is the level of trust. Many cloud computing providers trust their customers. So when they have the trust, they need to maintain the confidentiality, integrity, and availability of the client's data. But what if those inside are also evil? So we can trust the people inside our company to a greater extent as friends and outsiders and enemies. If the insider becomes evil, then what are the steps that we need to take here? So at client side, what all the attackers can do, what all capabilities the attacker can come in from is learn passwords, authentication information, gain control of the virtual machines. And after the client side, now comes the cloud provider. So what capabilities the attackers have at the cloud provider side is log client communication, can read and encrypted data, can possibly peek into virtual machines or make copies of virtual machines, can monitor network communication application patterns. And what is motivating the attackers to do this? Gain information about the client data, how they'll get into the data and the cloud is. They gain information about the client, they gain information about the client behavior, and they sell the information or use it itself. So attackers' capability outside the what are the attacker's capabilities if an attacker is from outside, it is not from the within the organization or within the client. So it is a third party attacker. So they listen to the traffic, they'll insert malicious traffic, try to confuse the traffic and probe the cloud structure, that how all what is all actually going onto the cloud, and what is the structure of the cloud, how the data is organized into the cloud, what is the login details of the cloud, and then launch the denial of service attack. So what all they can do, an outsider can do, is they can intrude into the data. They get into the cloud acting as they are the authorized users, and they'll man in the middle attack, which is a famous attack, that they come in between the client and the provider, acts as the for client they act as a provider, for provider again they act as a client, and in this way they can hack the data. Challenges for the attackers here. Now, how to find out where the target is located is the challenge for the attacker. So, if they find out that where the target is actually located and how to into the system, then they are half successful. How to co-located, how to be co-located with the target in the same physical space. If the attacker is in same physical space wherein they want to make intrusion, then it will be a very easy task for the attacker. How to gather information about the target. Now, second part, the security and the privacy issues in the cloud computing in a big picture we'll see. Data security and the storage now. So how all basically the data is being sent from the client to the provider, and how the provider stores the data, and exactly what's going on. We will try to see that here now. So it will include data in transit and data at rest. So basically, data in transit is the data that is being just transferred from the client to the provider. So here, these two things are mainly at rest. That is confidentiality and integrity. Before the data is put onto the cloud from the client, it might be modified by the attackers. And data at rest, generally non-encrypted, since data is commingled with other user data. And then what happens is encryption if it is not associated with applications. So data at transit is usually encrypted, but if it is not encrypted, then it is very easy. Very easy because it is in plain form. If it is encrypted and put onto the data, then the retrieval and the searching and the indexing part will become somewhat difficult for the algorithm. Processing of data includes the multi-tenancy also here. And the data security and the storage, it also contains, along with the data at transit, data at rest, and data processing, it also includes data lineage. What does data lineage actually means is, when you're storing data, you need to store data in particular address so that it becomes easy for the retrieval of the data. So at particular location, you need to save the data, and you need to know the location. So knowing where the data was located within the cloud is important for audit and compliance. Data provenance and data remnants also plays an important role for fetching the data back. So we'll see how actually the privacy of the client data is being breached. The concept of privacy varies widely among countries and jurisdictions. So it is shaped by public expectations and legal interpretations, but nowhere around the world you will find the definition of privacy as same. So what are the key privacy concerns for the cloud? Typical mixed security and privacy. Some considerations to be aware of is storage, retention, destruction, auditing, monitoring, and risk management, privacy breaches, and who is responsible for protecting privacy. These are all the privacy issues for the client and the provider of the cloud. So what are the solutions for? As we have already seen here, that the storage policies are to be laid down, privacy policies are to be laid down, retention, that if at all something goes wrong, who will be responsible and who will be prosecuted under or what, these all has to be laid down. So the solution part will be that if it is a third-party cloud computing, if the loss of control is happened, Then what is the mitigation solution for that is take back the control. Data and apps may still need to be on the cloud. If it is on the cloud, then you can just take back the control if you have lost the control. But can they be managed in some way by the consumers? So if the question arises, and if the breach happens at lack of trust, then you need to lay down the policies and contracts into the picture, so that if lack of trust happens, then the provider or whoever does the breach will be just prosecuted according to that policy. Multi-tenancy, if it is the issue, then you need to have your own cloud, or VPC is still a separate system and strong separation within the cloud. If you have got a good solution for strong separation on the same cloud for the multiple tenants, then you're good to go. So third-party cloud computing, known issues already exist. Confidentiality issues will come into the picture, malicious behavior by the cloud provider, and provider and infrastructure needs to be trusted here. And the new vulnerabilities and attacks on the cloud computing is a customer, virtual machine, and its adversaries can be assigned to the same physical server, and adversaries can penetrate the virtual machines and violate customer confidentiality. This is the main and a new type of vulnerability towards the cloud computing. Collaborative attack, if it happens, then mapping of internal cloud infrastructure will be a matter of concern. Identifying likely residency of target virtual machine is to be done. Initiating new virtual machines until one gets co-resident with the target. If your system goes down, you need to have a new system wherein your client can put their coming data, put their processing data onto that page, and again you need to, after your system gets up, you need to just cross virtual machine side channel attacks. Okay, so discussing more about the attacks and the mitigation. So what questions we can ask and what are the solutions that we can provide is like this. So can one determine where in the cloud infrastructure an instance is located? So a cloud, as already know, that it may be multiple tenants and single tenants and multiple tenants with a proper separation. So instance, if you need to find a particular information of yours, then you need to have an instance. So how well you can find that instance, and if you can find that instance. So yeah, it is very easy to find an instance from the whole lot of data, GBs and terabytes of data from the cloud. Minimizing the risk of trust. So policy languages are to be clearly laid down in this, and then the standard languages to convey one policies and expectations, and then machine understandable. If it is machine understandable policy language, then it is very good and easy to combine, merge, and compare, where the different sessions of data should be given. And then, in order to minimize the lack of trust part, certification plays an important role. So what exactly certification is? Some form of reputable and independent comparable assessment and descriptions of security features and assurance. Example of that is DISCAP. And another thing in minimizing lack of trust is risk assessment. So minimizing loss of control. After minimizing your lack of trust, you are minimizing loss of control. In loss of control, what you need to do is awareness of the critical application is to be done. And minimizing loss of control, it is broadly into the three sessions. First is monitoring. You need to monitor that consumer needs situational awareness for the critical applications. And then it comes in minimizing the loss of control, you need to have the different clouds wherein you store the data, so that if your single piece of information is hacked, the hacker cannot get the whole linked data if the data is stored onto the different clouds, and if you have utilized different clouds. And then same in minimizing loss of control, the access control is also very important. So there are many layers of access of control. The provider should give client particular access controls, and the provider should have particular access controls in order to safeguard the data and the interest of the client. And client needs to give some control of their data to the provider, and provider needs to give some control of their cloud to the clients, so that the business of cloud sharing, cloud providing, and cloud services should go in a smooth way. So if we see the access control, what all the access given by the provider to the client and client to the provider will be seen in this user diagram. So if we consider cloud provider in domain A and consumer in domain B, then the authentication request is sent to the identity provider, and then the resource policies are being laid down, and then what happens is a redirect to the domain of the service owner, retrieve the policies. If you are storing particular type of data, the policies pertaining to that will be retrieved will be given by the provider to the consumer. Then the consumer process that and sends back the signed and encrypted ticket to that, agreeing upon that privacy policies. So after saying this user diagram, that what are all the access control with the consumer and what are all the access control with the provider is clearly explained through this picture. That first it has been the consumer asks the provider some information, the user asks for storing some information, the policies pertaining to that particular storage is given by the provider. When accepted, and signed encrypted ticket is sent to the provider, then it agrees and then decrypts the signature, determines whether the user access specified the source, creates a ticket for the grant and deny, and then that is again sent to the provider. It will then decrypt and verify the signature and then deny or access based on the capabilities. If the control that is being asked by the consumer is acceptable by the provider, then it grants the access to the consumer. So now identity management is also very important for minimizing the loss of control. If on Amazon Cloud, if particular details of a consumer is stored, such as name, email, password, billing address, then it can be just used by the other websites or other organizations such as eBay, American Express, and FedEx from directly the Amazon Cloud. The information can be directly used. What all the information, if the name, billing address, and shipping address is needed from the cloud, the eBay will access that, depending upon the access control that is being given, and the identity management now comes into the picture here. So cloud introduces several issues to identity management. User have multiple accounts associated with multiple service providers. So present identity management of cloud requires a trusted third party and do not work on an untrusted host. Lack of trust. In lack of trust, how this identity management comes into picture is use of trusted third-party service is not an option. If you have not been given an option of taking a third party for this, then it will be a problem for identity management. You does not know that who is taking care of your data, and cloud hosts are untrusted. And loss of data is in what sense? It is that collusion between cloud services. Sharing sensitive identity information between the services can lead to undesirable mapping of the identity to the servers. Now, minimizing the multi-tenancy. After seeing the minimizing of loss of control, and before that we have seen minimizing of lack of trust, minimizing lack of trust, minimizing lack of control, and now minimizing minimizing loss of control, and now minimizing multi-tenancy. So lack of control, lack of trust, and then minimizing multi-tenancy. So can't really force the provider to accept the less tenant. So as we may require a very less space on the cloud, we cannot say the provider that don't take other tenants and give the space on the same cloud. So how can it be dealt is providing as we already stated, providing a separate isolation or policy specification and try to increase trust in the tenants. So after seeing what are the threats and how we can mitigate the threats and what are the minimization techniques that are available with us. So overall assessment that I could make with this study is the most. After performing this complete study on the security of cloud computing, the most representative issues that I found that contribute towards the security of cloud is confidentiality, integrity, availability, accountability, and privacy preservability. And the vulnerabilities that are most common for the security in the cloud are identified through this study, where bandwidth and the provision and collaborative monitoring, which may be exploited by the adversaries in order to perform various attacks on the cloud. So finally, I would like to conclude this presentation on security of cloud computing that however resources are ambiguous and they may be scalable and highly virtualized, but they contains all traditional threads to this cloud computing as well as the new ones. So if it is a new system and whether it is scalable, and if it is scalable and highly virtualized, you will find all the traditional threads with this. In developing solutions to cloud computing security issues, it may be helpful to identify the problems and approaches in the terms of loss of control, lack of trust, and multi-tenancy, and the steps in order to mitigate these all problems is also explained in this presentation. The references that have been used to make this study and this presentation have been listed in this slide. Thank you. Thank you for giving time for me to explain this study. Have a good day.